Okay, hopefully you guys got an alert that I'm recording it.
Yeah.
Okay, all right. All right, welcome then to Open Source Antibiotics Series 2 Research Progress Meeting on Friday, August 21st, 2020. This is just a quick update meeting after summer holidays and a bit of a break to catch up on a few of the things which hopefully are on screen there, which we are putting onto issue number 22 on the GitHub site for Open Source Antibiotics Series 2, diarrhyl. So we're just going to catch up on a few things and move forward some to-do items and catch up on chemistry. We didn't advertise this meeting, so it's the core team at the moment. All right, but after the meeting, I'll post a video and people can see what we talked about. Okay, so just the first item was the really crucial thing, which we need to get done, which is the measuring of the in vitro clearance and solubility of samples in this series, which are held at UNC and which need to be measured at Monash. And the two sides are now in touch with each other. So I got instructions from Karen White at Monash, and I forwarded those to Cara Wells at UNC for shipping of samples. So that hopefully is all done. The samples need to be shipped, of course, but we decided on the 5 samples and they'll be sent, hopefully ASAP, depending on how things are at UNC with the lockdown. So that's closed, and I've completed that action. All right. That is, the #1 priority, really, in the sense that this whole project is about trying to fix that clearance. So hopefully the data will help us to plan better compounds in the next round. All right, #2 is the mechanism of action stuff. So I don't think there's been any progress on this in the sense that we've updated lead grades at UNC with the idea of MRSA being the cell type we want to use, but I've had no other contact since then. So that action is on me to, so I know I completed on there. On #2, I'm going to write, this is also on me still, to chase Lee to try and do the experiment. I don't think there's any need for a delay here because we've got samples and we know what experiments need to be done. So it's just a question of hassling. All right, #3 is the same thing, I think. So it's just the same thing as #1. So this is all completed. I mean, in the sense it's out of our hands, but we need to monitor whether the samples are going to Monash on that. #4 is the MRSA and tox screening. All right, so I'm just about to get back in touch with Paul and Andreas to ask them about whether they have people in the lab who can do the screening versus MRSA and a generic sort of toxicology screen against mammalian cell lines. I'm pretty sure that'll be okay, but I just need to double check the time scale. If there's any further delay, I think maybe we vote to ship some compounds to COAD in the first instance, but let me check that. So this is TBD, action on me again. I drafted that email, just haven't clicked send. In terms of whether there was a backup, right? So our 2 options here are internally at SOB or at COAD. And I guess there was this question about whether there were any other options we could consider who might do this as a service. Did anybody look at that or has some thoughts about whether there was another service we could use, like the newly revamped Public Health England or something? Any other places that might do it in London or around? If you could Google search or something to see if there's anything that we're missing that might do it as a service, that would be very useful. Because I don't want to miss something obvious where we could just submit samples to get screened. All right, synthetic chemistry. So we can do an update here. Just on I saw that the slide that we had last time, we put on the issue for last time, which was great. If you can also just try and upload it to the file store, if you know what I mean. So the tab which says code has the shared file store, and there's something there for synthetic chemistry. If you could just additionally put the file there, that would be very helpful, because that's a place where people might look for updates. And yeah, I mean, I guess the PowerPoint's the main thing. ChemDraw if you want to, but PowerPoint's the main thing. So the last week one and this week's one, drag here and then upload would be helpful, just to keep it in 2 places. Degeneracy is sometimes useful. All right, so are you guys happy just to summarize where chemistry is up to?
Yep.
Okay, let me stop the show. Great. Okay, I'm seeing that.
Yep. Okay, cool. Yeah, so I've done the Suzuki's. The oxazole, I did not get the Suzuki products. I was getting mainly debromination of the starting material. The other ones, I've isolated, and they look good except for a weird peak in the chloroform NMR, which is not there in the methanol. I took one in methanol, and the LCMS looks good too. So I don't know. I'm not sure what to do about that at this point.
Are you talking about the top right?
So the top left, the product, the first three.
Oh yeah, sorry.
So 124, 125, and 126. I'm seeing the same thing. So it kind of looks like a water peak, except that it's at like 2.5. But it's sort of a broader singlet.
If you can turn it into a picture, you can drag it onto the issue and see what people think.
Okay, sure.
That'd be useful to see it.
Yeah.
But I mean, so in that case, the product that is formed is it in a decent amount, right? So it's like a big byproduct in DMK 127.
127. So I didn't see the desired product at all, and the major peak.
So you're getting an unexplained peak on all of them.
So the first three, those are the ones that have the unexplained peak.
Got it.
And the last one, I didn't run a column or anything. I just have the crude because I wasn't seeing the product on the LCMS, and I was seeing the debrominated starting material. So I don't think that Suzuki has worked at all for 127.
Okay, got it. I see.
Yeah.
Do you see conversion of things in 127?
Right. So I'm getting the debromination. So there's just a proton there, and then there's two other peaks, which they have mass on the LCMS, but I haven't been able to identify what those are.
Okay.
So yeah, I haven't tried to isolate them because I'm not sure how productive, how good of a use of time that would be. But I do have the crude material, so I can try to dig a little deeper on that one if you think it would be worthwhile. I don't know.
If if 124, 125, 126 are inactive, then maybe there's not that much point.
Yeah. Okay. So I'll set that aside. Yeah. And then I've also been looking at making the sort of just the imidazole core with either an NH or an N-methyl. So for the NH, I tried the Suzuki on just the unprotected imidazole, and I didn't get product. So now I've put a trityl group on it. So that's a literature procedure that I found. So the Suzuki, I think, has worked. I need to purify it and get the NMR to confirm that. And then it's just further steps to the desired product. Then I also tried to methylate the imidazole. I got a mixture of these two products where the methyl's gone on the other nitrogen. So I have separated them. And so now I just have to figure out which one is which. And then I can carry on with that also.
Right. Okay. Surprisingly annoying, actually, I imagine, trying to figure out which is which.
Yeah, I mean, I think I can do maybe an HMBC, figuring out which protons are coupled to the methyl.
Right.
Because this one should be coupled to 2 protons, whereas this one should only be the 1. So
Are they known compounds?
Okay. Yeah.
So they may have, if someone else has done the hard work, they may have defined shift for the protons.
Yeah.
Okay. All right, great. And so that would give us some variation there. Right, okay.
Yeah, so I was thinking if I have enough of, even if I've isolated this one, which is not necessarily the desired one, I can just see if I can make an analog.
Oh, sure.
Anyway.
Yeah, absolutely. Yeah.
Yeah.
And because the tritol doesn't have that problem, I'm guessing it goes on where the bromine is not.
Yeah.
Which is a neat part of it.
Yes.
Okay.
Yeah.
And if you get so the right hand structure, if you get that with R equals H, so in other words, if you take the tritol off, then is the idea to then put something on the nitrogen again, or is it just to have it as the NH?
We could. I was gonna just send it as the NH initially, and then with the smaller methyl. And then, you know, if the NH is inactive but the methyl is active, we can go a little further down that road. And or if the opposite is true, certainly we wouldn't necessarily want it then. Further. So.
Yeah, I mean, yeah, same thing. If you put an R, anything on that final compound through that route, then again you're likely to get isomers.
Yeah. Yeah.
But those could be sent as mixtures, because if the mixture is inactive, there's not much point in worrying too much.
Yeah, that's true.
So it's not as if you're generating a big headache for yourself.
Yeah.
All right, great.
Cool.
That's great.
And then, yeah, so for my stuff, so I finished off making those first top two compounds, just making the boron ester and then doing the Suzuki. And then I've been working on making these oxidized sulfur metabolite compounds. So for the sulfoxide, I tried to do it with hydrogen peroxide and I got the product in 42%, but then when I tried to do the borylation, like I couldn't really identify the correct product. So I repeated the oxidation with some different conditions, and I've got like some cleaner sulfoxide product. So I've put that on for borylation. It's going at the moment. The sulfone's a lot easier. That's just MCPBA oxidation, 93% of that. Borylation is also really good, so 68%, and I've put that on for Suzuki yesterday. So I just need to purify that, and I should have that one. And then the last thing was that we were thinking of making the derivative without the pyridine, so just with the phenyl. So we have, I guess, a control compound, because I don't think we have that without the nitrogen on that ring.
Okay.
So this first step is going at the moment. Based on lit, it's a lot nicer than with the 2-pyridine. So I think we should be getting high yields with that, and then just brominate, and then I guess couple with the benzothiophene to make that compound.
Okay. Yeah. I can imagine it is going to be nicer and less soluble, I suspect. I mean, aqueous solubility. But nicer to make as an organic chemist.
Yeah.
Great. Just so remind me, I should know this. That's the des amino, nitrogen version, the benzene equivalent rather than the pyridine. Have we got we've been making the 2-pyridine the whole time. Was the 3 and 4-pyridine in the original SAR? I think it was, right? And they weren't active.
Those were inactive.
Right. Fine. Okay. Yeah, I think those were, yeah, okay, great, that's fine. All good, correct? Okay. Let me do this, and okay, that's great. I think that's pretty much self-contained. Oops. That's very nice, though. What's so, I mean, at the moment, as things stand, if we were offered some, MRSA screening tomorrow, how many compounds could we send over? We've lost Dana.
Oh, I guess so.
Do you know how much it is? Like 5?
I've got 4 done.
Right.
And Dana's got, I guess, 2 or 3.
Yeah, it's like that, isn't it?
Yeah.
Okay, but it sounds, I mean, it looks from that as if we'll soon have sort of 10.
Yeah.
And then, yeah, okay. I mean, it's that number of compounds, so it's not 3 and it's not 30. Okay, that's important because that just gives a sense of load on the biologists.
Mm.
So 15 in 2 weeks or so. Great. Okay, just in terms of load. That's great. Okay. All right. The compound numbering is complete, so that's all done. Oh, yeah, there was something. There's a sneaking action on you here, Dana. I just stuck it in here.
Yeah, I did that.
Okay, fine. Great. On the wiki somewhere.
Yes, it's on the submissions section down at the bottom.
Great. Okay.
The spreadsheet link. Yeah.
This question about so pro bono biotransformation. So we're allowed to send a couple of compounds over to Scott. And also he's introduced me to a company called Haifa, which has been done. So I'm setting up a call with Haifa to talk about whether there's things we can do together, which is good. So that's done. But the question about sending compounds to Scott. So I guess what we want to do here is potentially send an active and an inactive to Scott to see if we can do some discovery of metabolites that might be active, right? So we must be nearly ready to do that, I guess. What do you think we need to do to finally send some compounds to Scott, maybe for him to have a look at? Can we do that? I think Dana's frozen again.
Yeah, Dana seems. Oh, jeez.
What do you think? Have we got active and inactive we can send now, or do we need to get that ready?
Do we have an inactive compound?
So I have about 100 mgs of the OSA 822, the thiophene. But that's one with the weird peak in the NMR. So once we resolve that, we can send it. And then
Right.
Inactive, I don't. Maybe UNC would have a stock of some inactive ones, but I don't think we've made any inactive.
I mean, if there was a trivial inactive we could make, then we would have a local supply of a control compound, which might be useful for the MRSA screening.
Yeah.
Can you see if there's one that we could get at in a single chemical step kind of thing?
I think probably there is. I think some of we would just need like a methoxyphenylboronic acid or something, which we would probably have. Yeah.
Yeah. Okay. Yeah, if there's something easy we could access and just keep it on in stock, that would be very useful.
Yeah.
Okay, we are parking the whole issue about whether there's some in vitro assessment of metabolic liability. So that's completed. I mean, we don't really have anything. And we need to wait until we've got the data anyway, but let's not worry too much about that for the moment. It's worth thinking about if there's something easy, but I don't think we need to worry too much about it. And then the similarity landscape thing. So yeah, I had a very good conversation with GSK guy, James Callahan, I'm sorry, just before I went on vacation. And it was a very useful conversation, and he's come back to me with another email. And what I'm doing is I'm just forwarding him a paragraph that is describing what we talked about to check that I'm allowed to talk about it. Because the series that they were looking at did go off in a different direction. And I need to be able to clear what I'm allowed to say. That's all. Because the conversation was confidential. So this is on me to just send that and get that cleared. He has, in the meantime, put me in touch with other people in GSK who I think are familiar with the anti-infective side of things, and so may have access to people who may have compounds. So that it's sort of an ongoing thing, but I got some useful information from James about the original series and what they did. I think, I'm not sure there's going to be a huge amount of stuff there for us, because I think that these compounds represent compounds that arose early on in a program, before it went in a slightly different direction for a different purpose. And so I think they didn't do a huge amount of sort of advanced PK work that might be useful for us on some of these compounds. But let me make sure that I'm allowed to talk about what was done, and I can fill everybody in. So that's on me. Okay, design criteria, keep an eye on log P. I mean, that's relevant to the phenol compound we were just talking about, but you know, we're all familiar with it. Oh, FAME, Chris did do that. So he did in fact do that. So I see contacted the team, they have emailed Matt, and Matt will digest it. All right, so there has been contact made with another team, and we can talk to them about it, but I haven't had a chance to deal with that email yet. Okay, target product profile. Oh yeah, so the target product profile stuff that we talked about, we were then talking about the activity against other bacteria, and I think you, Dana, in the previous issue, you mentioned something about the fact that we, well, it was something about what we had activity against, but I wondered if we found, did we find the actual original report from COAD?
So I just went on their website, so I put a comment on the other issue, but right. Anyway, I did go back. So the original focused array was screened in their, I think it's called like their primary screen or something.
Yeah.
And that's basically all the escape pathogens except the Enterobacter ones, which is the only other gram-positive besides MRSA that is an escape pathogen. So it was basically screened against MRSA and then several gram-negatives. So I think, well, anyway, it's just something to keep in mind that we don't know whether this is actually MRSA specific or whether it's maybe a broad spectrum gram-positive. And then it's just not active against gram-negatives.
Right. So it could just be a general gram-positive.
Yeah.
Okay, let's figure that out then somehow. I don't know how to do that, but we could use an evaluation against others then.
Other gram-positives, yeah.
I thought that COAD did like 5 and 2, but maybe I'm just completely misremembering. Maybe it's 5 bacteria and 2 fungal or something.
It is 5.
5 gram-negative.
No, sorry. 5 bacteria and 2 fungi.
Yeah, and so there are 4 gram-negatives.
Yeah.
Sorry, got it right. That's
what. And they weren't active against the fungi either.
Yeah. Okay. So. Okay. Fine. Okay, that's useful.
Yeah.
Okay, so we need to think about how to do that. I don't know. We need to figure that out though, because we are talking about this as being MRSA specific, but maybe it's not. So it's important. All right, I'm going to get rid of that. Get rid of that. Need to have this. Yeah, I'm going to get rid of that because you're going to put the stuff up there, and then you've done that bit, which is awesome. But we still don't, so we don't have the original screen, data from COAD right anywhere, which is a bit of a shame because we probably need that for a paper. So we might want to try and dig it out.
Yeah, I think Alvaro or Bill or somebody would probably have that.
COAD screen report. Right, fine. Okay. And then I might put in another, I'll digest some of these action items from the above and make sure that they're in here. Because there's quite a few here that are small, which we don't need to worry about right now, but I'll do that after the meeting. and finalize this issue in that case. Okay, and then we can finish this. All right. Okay, is there anything we didn't talk about that we should have? I think that's everything for the moment, right? Oops. Anything else that we have forgotten, or are we good? Are we good to go?
I think we're good.
I think we're good. All right, great. So the chemistry plan, though, is obviously to just finish the molecules that you're looking at now. Think about that, you know, simple, inactive, and then get them ready for shipping to wherever we decide to ship. So both for Mercer and for Tox and for Scott Obach's metabolic thing, right? I mean, that's everything, isn't it? So I guess we should aim to try and be shipping something in a week or so, ideally, hopefully, just to get things going on the biology side, right? I mean, I think that's about reasonable, something like 10, 15 compounds kind of thing. That would be good. All right, perfect. All right, thank you guys. I think that is where we are finished. So I will see you guys in the lab pretty soon.
See ya.
All right, see you.
Yeah.